This video is to discuss the basics of ratios, rates, and unit rates. So the first thing we need to understand about a ratio is that a ratio is a fraction that compares two quantities of the same units. So there's some important words here that we need to recognize. This part being fraction and the same. So when we're talking about a ratio, the units have to be the same. So what do we mean by something like that? Well, for example, let's say we were talking about 75 pages out of 90 pages in a book. This is a ratio of 75 to 90. We can see that they both have pages as units. If the units are the same, we don't necessarily see the units, and that ratio then, that fraction would stand, and we would just simplify that fraction. So we can write a ratio three ways. So the first is using words. So we'd say 3 out of 5 baskets. Another way to use words is to say 3 to 5. That's one way to use words as opposed to this. So this either way would work when we're talking about words. Another way to show a ratio would be to use a colon, 3 to 5. So we've seen this as well. But the way that we are going to focus more in on is this word. Remember we said fraction, right? So we want to focus on it more as a fraction. So we're going to look at it this way as 3 divided by 5 or 3 to 5 as a fraction. So using this as an idea of ratios, remember a ratio is a fraction with the same units. So now let's look at the next word, which is rates. A rate is a fraction that compares two quantities of different units. So it's really important to notice the difference between these. So a ratio is going to be with the same units, and a rate's going to be with two different units. So we'll come and talk about some of the different rates that we might normally see. So some of the rates that we might normally see are like miles per gallon, miles per hour, cost per item, earnings per week, words per minute, and my favorite, gallons per flush. Now these are all rates. We see them in everyday life. Now there's a specific rate which is called a unit rate, and what that unit rate is referring to is a rate for one item. So when we want to know the rate for one item, the denominator on the fraction has to equal 1. Denominator of the fraction has to equal 1. Okay, that's important. So that we were showing that it's a unit rate. Okay, now I'm going to say something about calculators because we get to use calculators in my class occasionally, and calculators out there for everyone. Basically, calculators are not very smart. Calculators are not going to tell you, hey, you're putting in the wrong number, or hey, you don't want to multiply, you want to divide. Calculators don't tell you that. And a calculator does not replace your work. What a calculator does is help you to make large calculations a lot easier. But you need to show all your work, all the steps, and then use the calculator to figure things out. So if you were to do something as complicated as just multiplying some decimals, and I'm making this up here as I go along, and dividing by another decimal, what you would do is you would break out the use of your calculator. So I've got one here, so I'm going to put in the calculator 2 6/7. Oops, got to back up. 2 6/7 times 4 356 thousandths. Now, we can agree that that's quite a big number, and that's quite a lot of multiplying. But if I had a calculator, look how easy this then becomes. So 11 63052. So I'm going to write that down. And then we're going to divide that by 5 3/800. So let me bring that back up. Divided by 5 3/800. So you can see where a calculator comes in handy, but it's really important for us to write down all the things that happen 2 and 1/6, blah, 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 blah. So it's important for us to use a calculator to come up with these numbers. But if something goes wrong, we don't know what number goes in the calculator. If we're not writing down our steps, we can't see where we went wrong in our calculation. So it's really important that you do that. So keep that in mind when it comes time to use a calculator. So let's dig into some examples here. So our first example is asking us to write this ratio two other ways. So here I have a ratio of 7 games to 12 games. So the other ways that I could write it is a fraction as 7 over 12, or with words, I could say 7 to 12. We'll do it again here one more time using this ratio of boys to girls, and they're all people, so it's considered a ratio. I can do it with the colon, 36 to 48. I can also do it as a fraction, 36 divided by 48. Now, one thing to do about when we are fraction, we always want to show it in simplest terms. So we can reduce this fraction of 36 divided by 48, and then that would become, by dividing by 12, that would become 3 to 4. So for every 3 boys, there are 4 girls. So we can kind of reduce that when possible. This is where having a calculator isn't really going to help you. You're going to be coming up with something else, and that's not necessarily the reduced ratio. So let's try this one now. Let's take a look at unit rate. Remember, unit rate is per 1. So let's first write the rate as it's listed. We have 9 pizzas every 12 minutes. So right now that's a rate, and we can probably reduce this a little bit more. But before I even get to that, I want to get a unit rate. So in other words, I need this to equal 1 minute. I need that denominator to be a 1. So the question then becomes, what will I divide by? So 12 divided by what gives me 1? Well, it's 12. And since we always touch fractions with fractions of 1, to make it either larger or smaller, that's what we'd use. Now here we have 9 pizzas divided by 12. We can put that in our calculator, and we can come out with 75 hundredths. So basically what's happening is that someone is eating 3/4 of a pizza every minute, or making 3/4 of a pizza every minute. It's a fast pizza maker. So we have a unit rate. Remember, it's per 1. Let's try this unit rate again. We're looking for a sprinter that runs 200 meters in 25 seconds, and it says, gee, she's fast. Well, let's see what's going on exactly. 200 meters in 25 seconds. And I want to get a unit rate, so I need it over here to equal to 1 second. I want to know, how far does this sprinter go in 1 second? So I need to divide it by 25 divided by what gives me 1? It's 25. And 200 divided by 25 is 8. So 8 meters per second, which seems kind of crazy, but you know what? I didn't tell you. She's a cheetah. A cheetah is one of the fastest animals on the face of the earth. So that's why she's so fast. Didn't tell you that up front, did I? All right, so we looked at how to write ratios. We looked at now unit rates. Now we're going to use where unit rates are going to help us with comparisons. So we're going to look here at this problem where Jeff hikes a half a mile every 15 minutes, or 1/4 of an hour. Lisa hikes 1/3 of a mile every 10 minutes, or 1/6 of an hour. So I want to know, how far do they hike in 1 hour, and what are we looking for? So remember, that's what we're looking for. How far are they going to go? So we're going to separate our sides here. And we're going to first talk over here on the left about Jeff. Now, Jeff, we know that he's going to hike a certain amount every 1/4 of an hour. So how many fourths are there in 1 hour? Well, hopefully you decided and realized that there are 4/4 in an hour. We know, based on this, what we're being told here, that Jeff's going to hike 1/2 mile every 1/4 hour. So each of these blocks then, each of these blocks are worth a half. So a half, there's a 1/4 of an hour, here's a 1/4 of an hour, here's a 1/4 of an hour, and here's a 1/4 of an hour. So together, I know if I added all these up, right, 1/2 plus 1/2 plus 1/2 plus 1/2, I get 4 halves, right? Because this is equal to 1, This is equal to 1, and 1 plus 1 equals 2. And doesn't 4 halves, 4 divided by 2 equal 2? So we can see this. So Jeff's going to go 2 miles. So at the rate that he walks, in 1 hour, he's going to travel 2 miles. Okay. So now let's take a look at Lisa. Okay, so Lisa over here, she's going to hike 1/3 of a mile every 10 minutes. So we need to build boxes for her too. And since it's 1/6 of an hour, in order to do an hour, we would need to show 6 boxes. So once again, when we look at what she's got going on, she's got of 1/3 of a mile every 1/6 of an hour. So let's put in every box 1/3. So 1/3, 1/3, 1/3, because we can see that's what's really happening every 1/6 of an hour, and it takes 6/6 to make 1 full hour, right? So if I count how many thirds I have, altogether I have 6 thirds. Well, we can see here that that's equal to 1, 3/3, plus this is equal to 1. So he also, just as she does like he does, she also walks 2 miles in that amount of time. Her pace is a little bit different, but that's what she walks. Now, there is an easier way to do this besides drawing boxes, because we can't draw boxes all the time because some of the numbers will be just too big. So what's another way for us to get to this answer right here without drawing these boxes? Well, we know that it's 1/2 of a mile. And how many boxes did we need? We needed 4. And isn't 1/2 plus 1/2 plus 1/2 plus 1/2 the same as 1/2 times 4? Sure. So remember about multiplying fractions by a whole number. We need to put a 1 underneath it. Multiply straight across, we get 4 divided by 2. And that's what we came up with before, isn't it? Same thing. So let's take a look at Lisa. She'd be 1/3 because that's her rate, right? 1/3 of a mile every 10 minutes. And we needed, though, for 1 hour, so we need 6 sets of that. 10 minutes, 10 minutes, 10 minutes. It takes 6 of them, right? So we're going to multiply it times 6. Here we're going to multiply straight across. I get 1 times 6 is 6. 3 divided by 1 is 3. And 6 divided by 3, there's our 2. So we can see that we can do this also by multiplication. We don't necessarily have to draw boxes, but I'm hoping that the boxes can help explain to you where these numbers come from and why we choose those numbers. Most students want to just grab 1/2 and 1/4 and start multiplying, but we can see that that's not how it works. So you really need to understand what the working behind it so you know what to do. So let's do one more problem here, which is pretty typical of how we use unit rates. We have 2 water heater tanks that are leaking. Tank A has leaked 1/16 of a gallon in 1/12 of a minute, and tank B has leaked 3/80 of a gallon in 1/30 of a minute. Which tank is leaking faster? So we're going to set up our problem here. We're going to have tank A on the left, and we'll have tank B on the right. And we're basically trying to find out which tank will run out of hot water first. Okay, so let's set this up a little bit. So in tank A, we know that we're going to multiply. Let me get a little highlighter here. We're going to multiply 1/16 of a gallon by a number. And in tank B, we're going to multiply 3/80 of a gallon by another number. So let's set up for tank A. We're going to take that 1/16 and we need to multiply it. How many 1/16 do I need for 1 minute? Because these are portions of a minute. We're going to look and see for how many of these portions do I need for 1 minute. Well, on the first one for tank A, I would need 12 boxes, right? So instead of making 12 boxes, I could just multiply it 12 because I need 1/16 plus 1/16 and so on. This first one, we're just going to multiply straight across in case you've forgotten about how to reduce things up front, but we're going to do it there. So I have 12/16. I know that I can reduce 12/16 because 4 goes into both numbers. And what that leads me to get is 3/4. So I know that in tank A, I'm going to have 3 gallons is going to be leaked out every 4 minutes. Okay, so now let's run over here to tank B and see what's going on. So we know that we have 3/80, and I need to multiply it, so it's 1/30 of a minute. So how many of these do I need to make a full minute? Well, I need 30 of them. So we're going to multiply it times 30. And once again, a whole number goes over 1. Now, before I just multiply across and do some dividing on this one, I'm going to show you canceling. Remember, we talked about how to do that. So 80 would be 8 times 10, and 30 would be 3 times 10. So the 10s would cancel, right? I don't need the 10s anymore because they're gone, because we're dividing it top and bottom by 10. So once I've done that, I can multiply straight across. So 3 times 3 is 9, and 8 times 1 is 8. So what we find out here is that this one's going to leak 9 gallons every 8 minutes. Now here's a problem. We're not comparing the exact same thing. This one's in 4 minutes. This is in 8 minutes. We can double. We can do all kinds of things. But what we normally do is when we do comparisons is that we want to get it to be a unit rate. So I want to divide this by a number so that I end up with 1 minute. What's that number going to be? Well, it's going to be 4, because 4 divided by 4 is 1. So this 4 over 4 is going to help us. And we know that 3 divided by 4 is 75 hundredths. So 75 hundredths gallons, or 3/4 of a gallon every minute. Let's do the same thing over here with the 9 gallons in the 8 minutes. We're going to divide by the whole number of 1, but we're going to use a fraction of 1, which would be 8 over 8. And then we're going to do some division. So we know that this will have a denominator of 1 minute. And here we have 9 gallons divided by 8. So I'm going to bring my calculator back up and say, I'm going to clear this out and say 9 divided by 8. And we find that it is 1 in 125 thousandths. So 1 in 125 thousandths gallons. Now, when we look at this, we can now determine what's really going on. So over here, this one is 75 gallons a minute, or 3/4 of gallons a minute. This is more than 1 gallon a minute. So we see that tank B, this is the one that's leaking faster. Tank B is going to run out of hot water before tank A. So I'm hoping by you watching this video and seeing how we use rates, unit rates, and ratios to help us do problems in real life.